Well, welcome everybody to the September meeting of the Ottawa RASC. I'm glad you could all make it. It's nice to see a fuller crowd there. I guess we're past the summer vacation stuff there. We've got an excellent program for you tonight. We've got a couple of really interesting talks, a little bit different than we've had in the last little while there. I think you'll find them informative and entertaining. So yeah, I'm quite looking forward to them myself. Tonight's program, essentially, we've got Gary Boyle. I did see Gary kicking around there, so I'm assuming we have our Ottawa guys. Then John Wayne Ross is going to give us our first major talk on planets of the gods there. I think you're going to find that quite interesting. And Chuck has offered to do something that some of you may remember from previous meetings, where he used to chuck out trivia questions just to make sure that you guys are paying attention. So he's graciously offered to generate some of those, and so we've got our first one tonight. We'll do the question before the break and provide the answer afterwards. There, we have our usual break and our goodies there. I thought we were going. I thought I was going to disappoint you tonight with the goodies. The cupboard was pretty bare, but folks have stepped up to the plate there. So we've got some nice giveaways, including some nice images that I just got from Rolf Meyer. So then, we'll do our trivia answer afterwards. Chris is going to talk about Starfest a little bit there. We've got some interesting observations, including of the recent Nova last month. And then Frank Roy is here to talk about a rather ambitious project that I hope he has success with, about building a professional observatory and education center up in the Madawaska Highlands. So he's going to give us a rundown of just what he's got in mind with that. I think you're going to find that interesting. All right. We have a few members in the news. I wonder who did that. Any idea? Pierre Martin, of course, meteor photographer superb, has a really nice shot there. I always love the way he does that. That's the Geminids from December there. You can see Orion kicking around there, and just a beautiful composition of numerous bright Geminids. Sky News there.
Notice that wasn't just a normal image. That was a photo of the year.
Oh, that's right. Too.
Winner for photo of the week.
I stand corrected. That's right. It was the photo of the week there. But yeah, as you can see, best deep sky with a webcam type imager. So pretty amazing. I think Pierre deserves a round for that. Then we have down below there. Oh, you managed to clean up the scan there a little bit there, right?
The projector fixed it.
Oh, was it the projector? Okay. Another superb image from Mike Wirtz, who is our remote member of the club there. Getting a beautiful image of Saturn there from his stable skies down in Baja, I would imagine. So nice piece of work from Mike there as well. Yeah. Here you go, Mike. Clap loud so you can hear you. I think that was. Oh yes, of course. Then Rob, is Rob here tonight? Yep. Oh, you are here. Okay, I didn't see you. Congratulations, Rob. This is wonderful. This an article in the Frontenac News concerning the Dark Sky Preserve and Rob's involvement in that. And good on you, Rob. That's excellent. I was up in that neck of the woods just recently. I wasn't doing any observing there, but what a splendid sight up there. It's dark sky supreme there. So if you get a chance to go out to one of the two sites up in that neck of the woods there, I highly recommend it, especially before it gets wintry on us there. But again, good work, Rob. That's excellent. Should get most of the province declared a dark sky, so that would be cool. All right. Up first, Mr. Boyle. There you are.
There he is.
Come on up.
Thank you, Dave.
You're welcome.
Well, good evening and welcome to another month of Skies Over Ottawa. Yeah, well, no, we've had some clear nights, especially South Mountain, really dark up there. Can I see a show of hands, any observations from the last, not clouds, I don't want to hear clouds. Okay, good. Anything interesting or discoveries? No? Okay. I mean, mosquito bites. Lots of mosquito bites.
Something there.
The night's getting cooler. There were none last night, that's for sure.
No.
Okay, next slide, please. Okay, who has seen the Nova? Nova, lots of pretty good show of hands, what I can see. Yeah, a couple days after the Perseid meteor shower, which peaked on the 12th and the 14th, there was a newly discovered guest star in the sky. And as you can see, pointed with the two arrows. It was, I think it went to about 6 magnitude, I think even more, 4.6.
4.5.
4.5, yeah. So I imaged this on the 15th, pretty well at its brightest, was brightest the night after, it's going to be the brightest, but clouds are just too busy, so. Yeah, 80-second exposure with my Canon 450D, but it's really subsided now. Oh, the laser pointer is, it's subsided to about, looking at this morning, to about this brightness now, so it's really come down. So it's still there. If you want to find it, it's just get on the net, and there are many finder charts. But I have one. Next slide. Pretty easy to find. It's just look for the green star in the sky, and it's right there. So if you take Delphinus, the dime Delphinus, it's about four radii. Easy to find is you look for this bowl of stars, this little hook, and then two above that, and it's right here. And it's just with relation here. But again, there are charts on the internet to show you where to find it, the general area. But pretty neat. Next slide.
What scope was your shot on, Gary?
No, that was just with the
Telephoto?
Canon, and that was on a tracker. Yeah. So what is the process that causes a nova to occur? Well, unlike a supernova, where a star completely explodes pretty well to about 80% of it's gone, but we have a very young white dwarf star close to a very large old red giant. And just like the sun, when it becomes a red giant, it just gets so large that it can't hold itself together pretty well, so it fluffs off some gas. So it's easy to steal. So this young guy actually steals the gas and dust around, essentially like a balloon that just builds an envelope around, and about 20 million degrees, or about 20 million degrees, it blows its stack. The star is still intact, but it's the outside envelope that has blown up for about 2-3 weeks, and that's what we saw. Okay, next slide. Too bad that animation didn't work.
Which one?
Oh, if you go back, on the bottom right, that it flickers back and forth. Yeah. Oh, maybe if you
Don't
click
know.
on it. I doubt it. Okay, maybe not. Don't worry about it. It was just the before and after of the actual star. So here we are, winter's coming, Orion. It was like this, it rises about 2:30 in the morning. This is about a 3 a.m. shot. Very bright area of sky, the brightest 12 stars of the northern hemisphere. Between Orion and Castor and Pollux, Jupiter, Procyon, Sirius. So just a very great area of sky to observe. So do it now while the bugs are biting. This is almost like Florida observing. To look at Orion when the bugs are out just never happens. It never happens. So many great objects in that, but just to sit back and look at the sky is therapy right there. Next slide. On the morning of September 8th, just a Monday? Yeah, Monday or Tuesday. At 5 a.m., look for M44, the beehive. But the great thing is Mars is embedded right in the beehive. So the morning of the 8th, it's here, and then the morning of the 9th, it's over here. So it's a great digital moment. But if you have a wide-angle scope, and before you go to work, that's a great thing now. It stays dark a little later.
Sunday.
And Sunday? Okay,
Yeah.
Sunday? Great.
So you're better.
Even better. Even better. Before you get ready to go to church, you look at Mars. On the shirt and tie, and do your best luck. And here's the supposed photo. Yeah. So that'll be neat to see. So let's hopefully we get some observations for next month. Next slide. And also the night, just about 13, 14, 15 hours after that, we get the 13% lit moon along with Venus, and that'll be a nice, again, digital moment too. So no excuse not to image, especially at 8 p.m. unless you get to bed really, really early, or you've been a bad boy or a bad girl. Next slide. The zodiacal lights. I think I saw the zodiacal lights this morning. I wasn't sure. It was right along the Milky Way. I think I saw it. Being in South Mountain now, I've got country skies, and so I think I saw it. I did image it, but only about 30 seconds. That wouldn't be enough to see anything, I think, zodiacal. You really have to expose a couple of minutes. I've never done
I wouldn't think so.
I've never done the zodiacal.
Depends
so
on what you're shooting.
I just get this one off the net.
We expect one next month, Gary.
Coming up, for sure. I'll track it and get a better one. So, but it moves pretty high in the sky. It's about 40 degrees in the sky, pretty high. What it really is you're looking along the plane of the solar system, and we see this in the spring and in the fall when the sun is due east or due west. So really, this is just all the interstellar dust being lit up by the sun. That's why you see it during this time of year and in the springtime. Next slide. And tomorrow, fingers are crossed, it doesn't look good at all for observing stars and planets, whatever, but the next organized star party will be tomorrow at the Diefenbunker at the Carp Library here in the parking lot. So stay tuned to the website, ottawa.rasc.ca, for a go and no-go. I think around 12 or 2 o'clock in the afternoon, it's usually updated. But for now, it's not looking good. But you never know. Let's hope. Next slide. And here's your favorite lunar phases. The harvest moon, it will be on the 19th. So again, good imagery. Next slide. And I invite you to my monthly column I write for the RASC National. The link is on our website again. And this month I'm speaking about Aquila, the many planetary nebulas in Aquila, and a couple of things, including Comet Ison that's coming up in a couple of months. For now, the observations are it's 2 magnitudes fainter than what it should be. So it might be the daytime object, or it may be a great dark object, dark sky object. Let's hope and see. Next slide. Yep, there's Aquila. All the blue ones are planetary nebulas. And here's Altair, Sweet 16 star. In fact, this star's orbit spins once in about 4 hours. It's almost squishy on the sides because of the centrifugal force. Next slide. And a couple of months from now, save your pennies. Of course, Gordon Webster, our vice president, sitting in the back. He's waving in the dark, which I can see him. He'll be selling tickets. They're $42 like last year. They haven't changed, which is good. We do have more than one ticket, so don't all rush him for that one ticket. We had the standard 100 tickets being sold. Again, the great buffet, door prizes. This should be a great night. The speaker we do not have yet, but hopefully by next month we'll know who will be speaking. But we go there for the food and the ambiance and clashing with our neighbors. And next slide. And that's it until next month, folks. Good month observed.
Thanks, Gary.
Thank you. All right. Without further ado, Mr. Ross, where are you? I know you're here because I talked to you.
Wake up.
He left. John.
And by the way, the G on God I probably should have made. Oh, it is. Thanks, whoever made it lowercase.
Chris is good like that.
I like that. Thanks, Chris. I really do appreciate that. You see, this is my timer. I often lecture. I travel around. Last while I've been traveling in Europe, speaking as part of my job. And one of the things that interests me, I'm a philosopher by education. I can't see anybody, so if everybody leaves, I'll just keep talking. I still won't know you're gone. I'm a philosopher by education, and I've been passionately interested in astronomy ever since I was young. So I studied cosmology and antiquity, but I'm also very interested in ancient history. And recently, a couple months ago, I was actually in Europe and giving a talk in London, England. And I went down to Italy, and I hooked up with. I didn't hook up. I went out with. This is because my wife's not here. She'd be very embarrassed with this. With an archaeologist from Harvard, and we went to Ostia, and we got underground, and we were climbing around, just absolutely filthy. It was delightful. I was there for a week. And crawling around on site. So most of the pictures I'm going to show you tonight are photos I took on various exercises like that. And just a quick little side on the background. Here in Ottawa, we have an archaeological history most people are unaware of. Last week, 2 weeks ago, I was on a dig here in the city, actually. And I found a 1,000 to 2,000 year old piece of pottery that was pre-European, which is kind of cool that there's this history. But all of this history that we have comes to us in different ways. And one of the things that's most commonly recognized to us are the names of the planets. And we know them all as Roman gods, hence the planet of the gods. But they're not just Roman gods. They go back for millennia. And if you look at the International Astronomical Union's website, and I'm using that only as one reference for the numerous websites or numerous publications that are out there that give reasons for how these names came about, you'll see a set of explanations that are, Mercury was named Mercury because it's the fastest. Venus is beautiful and therefore beautiful. Jupiter being, the head of the pantheon of Roman and Greek gods is so named. So, can I advance it with this?
Yep.
Okay. So
Right
do I have to point it in?
The right button, no?
Excellent. So, tonight I'm just going to cover a little bit about how these names may have come about and a couple of academic questions. When I get into this, I actually thought this would be fairly straightforward. I ended up yesterday on the phone with York University with a guy through grad school who teaches philosophy of science, with one of the questions that came up, and I've even talked to a couple of theologians, and none of us have an answer for the question I'll bring up in a bit. But just two methodological points. When you're engaged in looking at anything in antiquity, you have to be very careful that the sources you're looking at, you have to be aware that they've been translated, and the original texts are often lost. So you're dealing with things that have been translated either into Arabic, then from Arabic into Greek, and not just any Greek. It's a very specific type of Greek. Usually it's Attic Greek, which is Athenian Greek, the language of philosophers. And it's not the same as contemporary, even though contemporary Greek speakers and readers can read it and understand it. Latin, and you're dealing with a type of Latin that's not ecumenical Latin, which is the Latin that comes from the church. So the truth also that people are trying to convey is more the general story. It's like going to a movie and you see the movie based on actual facts. It's kind of loose with the details, but the general story is coming across. So when you're looking at ancient scholars and you're trying to figure out what's going on, you're getting a general story, and some of the details, while they may be correct, are hard to interpret and require looking at a lot of different material. So I looked at about 20 ancient texts, and some of them in Latin, and conferred to some other people on the translations, to try to get to an answer as to how we ended up with the names of the planets. So one of the things that complicates our understanding of antiquity is that through this process of translation and through this process of information being passed down, we have gaps. And these gaps may go for hundreds of years and then reappear. And we get often presented to us like we talk about the Colosseum in Rome, the idea that it's a continuous history, when in fact it's not. Our evidence is broken. There may be a gap of 75, 80 years, and a lot has changed. I mean, just think what happened in the last 20 years, or the last 50 years. Things have changed. So an example is of this phenomenon is that a lot of the texts have been altered. Particularly in the 9th century to the 12th century, many texts had information added to them to make them more understandable to people at the time. And this isn't lay people. The average person couldn't read. These are people in monasteries. These are individuals who may be studying early, when we talk about the early scientific revolution, pre-Copernicus, and coming up to him. So, for example, no diagram of Plato's cosmological model actually appears in copies of Plato's Timaeus, which is one of the principal texts on astronomy from Plato, prior to the 12th century. It's in these models that are published after the 12th century that we begin to see singular names for planets appearing. As I'll show you, there are many different names for each planet that the Romans gave them. And somehow we've ended up with a single name at the moment for these. In his article on Hercules and heliocentrism, Eastwood says the manuscripts of Capella, Macrobus, Bede, and Plinian astronomical concepts all had diagrams added to them or consciously were altered to accord with the sense that made, i.e. the worldview of people between 900 and 1300 CE, such that this inventiveness has altered the original conceptions of things. So in the Ptolemy's famous work, the Almagest, Almagest, I'm always terrible at pronouncing that one word. Some of the copyists had actually altered them and made complete messes of them, and they had to be, individuals were doing scholarship based on faulty documents. And then only later, in closer to contemporary times, do we actually find texts from different countries, different sources, that we can then isolate what is actually being said, or what's more closely to the truth. So enumerating factors as to how to associate the names with ancient gods is kind of a speculative effort, even though it's based on what other people have said. So what we have here, for those who don't know, the Greek word for planet is planetai, and it just means wanderer. And the prevailing view throughout antiquity that these wandering lights in the heavens were stars. Forget everything you know about them being terrestrial bodies or gaseous bodies. Prior to the invention of the telescope, these were lights. Now, Democritus and Leucippus being Democritus' teacher, hypothesized that these were actually terrestrial bodies that were made up of atoms. And they had atomic theory that was not quite what we have today, but it was pointed in the right direction, which was lost out, if you will, in the competition for the dominant worldview with the Platonic view, which basically dominated up until at least 1543. So the planets were not thought of in the same order as we think of them. Does this do the laser? Okay. So just quickly, you can see in the Platonic order, most notably you see the Earth is at the bottom, it's geocentric. The Sun is here, Venus, Mercury, Mars, and the outer planets. Here in the Ptolemaic order, you have them reversed, more properly, but still reversed. And this is actually quite important to the naming of Mars, as you'll see in a bit. So, there we go. So quickly, I'll just go over some of the gods that our planets are named for, and what the Romans particularly conceived of them as, just to give you sort of a quick little exercise in ancient mythology, for which I'm not an expert. Mercury is the god of commerce, thievery, and travel. May come as a surprise to you. The members of the Guild of Merchants in Rome were called Mercales. The word merchandise, ever wonder where that comes from? Mercury. Mercury was called by the Greeks Hermes. And yes, he was a messenger of the gods, but it's not a messenger in the sense of UPS or FedEx. He's an interpreter of the will of the gods. And when I talk about the Babylonians in a moment, you'll see how they conceived of the planets with the notion of divination interpretation. And this feeds into astrology, which I'm going to avoid, by the way. I just don't even want to go remotely close to that. So Venus. For the Romans, Venus symbolized imperial power. And this may strike you as odd for the god of love, goddess of love and whatnot. But she was a fertility god to the Romans. They called her Venus Genetrix, which basically means Venus creator. And of the creation myths for Rome, now there's several stories of how Rome was founded, one of which has Venus as the mother of Aeneas. You had the Trojan War, he fled Troy, ends up in Italy, helps found Rome. That's one of the tales. Another one has Mars, who was the father of Romulus and Remus, who then, Romulus Wax Remus, founds Rome, and hence the name Rome from Romulus. But the oldest reference to Venus comes from 217 BCE for the Romans. And this is after the battle at Lake Trasimene, where Hannibal thoroughly beat the Romans. Romans were pretty freaked out. They lived in constant paranoia that they were going to be conquered, because Rome had actually been sacked by the Gauls at a much earlier date. So they lived in this institutional paranoia that barbarians are somehow going to do them in, and Hannibal just epitomized all this stuff. They used to actually scare their children with stories Hannibal will get you if you're not a good little kid. But the Sibylline books, which are these texts which come from Cumae, which is an old ancient, an old Greek settlement near Naples, actually. You can still go to the area where the prophets were. Said that build a temple to Venus, will gain favor for her for victory in battle. So the Romans actually prayed to Venus for victory in battle. And she became known, very strongly associated also with fertility and vegetation. Pliny tells us that Venus is the cause of the birth of all things on the earth. And the Greeks called her Aphrodite, and she was indeed associated with beauty and love. But be aware that anybody who's familiar with Greek mythology will be aware that when they say love, it's a double-edged sword. You fall in love, something really crappy is going to happen to you. Something bad's going to happen to you. There's never a win-win in this thing, right? And these folks, I mean, you couldn't put this stuff on HBO because it would be just like off the charts, out of control, just the foolishness that the Greek gods got up to. Mars. Mars started out as the most powerful agricultural god for Rome. And you're noticing there's a theme. Rome actually, a lot of their original festivals and their gods started out agricultural and changed over time. They adopted through a process of what Tacitus called interpretatio, or modern scholars would refer to as a synchronism, where you begin to take on the names of other divinities, philosophies, and cultural aspects as your own. You sort of absorb them naturally. And you see this happening. I'll talk about it in a second. So he was a protector of fields and herds and was associated with spring. And every October 15th, a horse was sacrificed to him to ensure the good growth of next year's crops. He was always invoked whenever fields were planted and to prevent harm from coming to crops. I mean, the Romans also had gods for things like rust on plants. door hinges. And they had a whole whack of things. It was just, you wouldn't believe, they were probably the most superstitious society you could ever imagine. Just bananas. However, as the Roman Republic faded and was replaced by the Principate with Julius Caesar after he was assassinated, and the first emperor, Augustus, Octavian, in 2 BCE, he repurposed Mars into Mars Ultor. Ultor is Latin for vengeful, or vengeance. So he was Mars the Avenger. Now, an interesting story is, anybody been to Rome here? Okay, and you've driven down the, you know, the Colosseum is? The road that runs from the Colosseum down to that gigantic Vittorio Emanuele monstrosity that's at the end of the Roman Forum behind the Curia. That road was built by Mussolini right over top of the temple of Mars Ultor. The new mayor of Rome, and the archaeologist I was with a couple months ago, was talking to the new mayor of Rome, and he said that he was actually going to shut that down and dig the road up. Well, they've now done that. They shut it down. Only buses and taxis and bicycles are now allowed in there, and they're eventually going to dig that road up. So a lot of information about Mars as this war god will become revealed to us, because this temple should be uncovered and a lot of archaeological evidence will be made available to us. Right now, it's something we don't have. So the Greeks called them Ares. When we get to Jupiter, and I'm going to skip Jupiter and Saturn, I'm not going to spend much time on them because they're not really as interesting as the inferior planets and Mars. He was the head of the pantheon of gods, both for the Romans and the Greeks. He's associated with the color red. Roman generals, when they were celebrating a triumph, painted their face red. They went to the temple of Jupiter and they sacrificed, and it was usually, the general of the opposing army was usually sacrificed, not in a human sacrifice way. They executed him. Romans forbade human sacrifice. So the association of red with Mars, you kind of ask yourself, well, red's really important for Jupiter. Where do we get this Mars thing? We'll see. We'll talk about that in a second. But also, red was associated with almost every other god. They really didn't have a big color palette. They really didn't. And some of the stuff, I don't know if you've ever seen, the Romans actually painted their buildings and their statues. It wasn't white at all. That's a concoction of the Renaissance period. But the colors they had are just they're horrible. It's like the standard Windows palette. So, it really is. It's spectacular. And red and blue figure prominently. Purple doesn't. You get a whole lot of trouble using the color purple, mostly because of the means it was made for, how it was manufactured. So we see Saturn was Kronos. I won't go into the story about Kronos because it's disturbing if there's kids in the audience, but he's the father of Zeus, and he's primarily an agricultural deity. And we still celebrate a festival through this process of synchronism on December 25th that was originally the festival of Saturn, Saturnalia, which we now call Christmas. A lot of the activities that go on at Christmas actually were the same activities the Romans engaged in, giving gifts, singing, all sorts of stuff like that. So a lot of the information that the Romans have came from the Greeks. Their gods are translations in many regards of the Greeks. And what we have is the Romans were obsessed with all things Greek. The Greek ideas of the planets and the Roman cosmology came from the Greek concepts of cosmology. The ancient Athenians were so obsessed with knowledge themselves, they actually sent emissaries out to various countries throughout the known world and collected their libraries. And one very famous anecdote, possibly apocryphal, but probably not, they offered gold to one of the kingdoms to copy their library, and then stole the library and left the gold behind. Shows you how important knowledge was to them. So they were trading in knowledge. The Roman philosopher Seneca said in his Natural Questions that Eudoxus, around 408 BCE, he was a student of Plato, was the first to import from Egypt into Greece knowledge of the movements of the planets. So now we're getting a definitive, or a date placed from antiquity as to when this information began to come into the Greeks. So, unfortunately, my photo of what's coming up, which is really, really cool, didn't turn out. So I'm going back to giving a talk in London in another couple of months. I'm going to go to the British Museum and re-photograph this. These are all my photos. The Roman historian Diodorus tells us that the Babylonians commonly called the 5 planets interpreters. These are interpreters of the wills of the god. And a discussion in the American Philosophical Society from 1908, it just goes to show you how to find this information. I had to dig into stuff like from 1908, from 1915, even to the 1800s, some of the articles. They come to sketchy academic standards at that point too. They mentioned at that time that the Babylonians metaphorically conceptualized planets as sheep that had wandered from their flock. So the stars are the flock and planets have wandered away. And the word at the time that was being discussed in the Philosophical Society proceedings was lubat. And this is what they believe the Babylonians called planet. And it basically means sheep omen. Lu meaning sheep, bat meaning dead. And I'm not speaking in proper Babylonian, trust me. So it probably sounds differently with someone who knew what they're saying was saying it. So basically, when a sheep was sacrificed, the priest reads the sacrifice, particularly the liver. And if the rites are performed properly, the sacrifice and the god they're synchronized. It's like watching two watches, they're exactly on the exact same time. So by looking at the sacrifice for a brief period of time, you can see the will of the god. You can interpret all these bumps and foolishness like this. So they are associating the gods with the planets. The planets are telling them when to do sacrifice. They believe the planets are interpreters. They say, here's a time that something's going to happen, make a sacrifice so we can get insights into what's happening. So we see sort of a reason for why this is occurring. This is the Venus tablet. This is cool. This, and I had to take this from science because my photo of it has actually been messed up. This is the oldest written record we have of an astronomical observation. I mean, there's a specific astronomical observation. This actually covers serocycles. This contains a record of 21 years and mostly consists of omens related to Venus. It's the heliacal risings and settings of Venus in the form of lunar dates. And this is a first and last visibility of Venus on the horizon. And this is from 7th century BCE Babylon. All right, that one didn't turn out quite as I hoped, but that's it.
Can we go back?
Sure, yeah, flip back. There you go. So these are actually all from Pompeii and from Herculaneum. They're taken off the walls of places and discovered. So according to a text written in 1890 on Antiquities, the first mention of the planets as gods in Greek philosophy appears in the Eponnius, which is a text that's attributed to Plato. There's debate as to whether he actually wrote this. A philosopher near the time, Diogenes Laertius, said no, he didn't. We don't know who wrote it, but it's basically ascribed to Plato, and it was believed to be an annex to a text he wrote after the Republic called the Laws. So he tells us the planets were created in order to distinguish and preserve numbers of time. Essentially, Plato is telling us that the planets were created by the gods as a way of keeping time. Ironically, that's actually one of the things that the planets were used for, when you look at astrology and other things like that. So he sees the 5 planets named. This is the first time that we actually get the 5 planets named in classical literature. Mercury and Venus are said to be nearly equal in velocity with the sun and are neither slower nor swifter than each other and the sun. They're all operating at the same speed. Lucifer and Hesperus are the same, having the appellation of almost Venus. By the way, I'm actually reading you verbatim what was written. I do agree. The star which revolves with an equal velocity with the sun and the Lucifer has the name of almost Mercury. Notice as I go through this and I start talking about these things, at no point do you hear the planet called by the name of the god. It's almost, star sacred to, so on and so forth. So it's interesting that they use this terminology. Saturn, it goes by the name of Phaenon, which is actually just, it's a boy that Prometheus created. Zeus fell in love with him, got really PO'd. That Prometheus didn't tell him about him, so he sticks him up in the heavens. Jupiter appears as Phaethon, which is basically the same deal. It's the son of Helios, the son. He's driving his chariot, dad's chariot, wipes it out like all good teenagers do, sets fire to the earth, creates the deserts in Africa. Zeus is really PO'd at this point. Zaps him with a bolt of lightning. He's like, oops, killed him. Which, and dad is now really upset. And being a sun god, these things aren't working out in the pantheon in Olympus. So he goes, okay, I'll tell you what, I'll give your kid to pop him in the heavens. He becomes Saturn. This is one of innumerable myths related to the gods. There's many different interpretations of them. So, Mars is called Pyroeus, which means fire. Now I mispronounced that, but it's Pyroeus, I believe. It's based on the ancient Greek word for fire, and also one of the horses of the chariot of Helios. It's also named Mesanix, which means midnight star, and sometimes referred to as the star that belonged to Heracles, or Hercules. I like to say Heracles, it's what the Romans used to refer to Hercules as. And is also associated with Aries. Let's zip ahead because of the time. I only have 3 more slides to go. So, the basis of Roman philosophy, as I mentioned, is found in Greek philosophy. And good insight is provided by Cicero. And I love Cicero. Cicero was like the ultimate curmudgeon, eh? Anybody ever see the series Rome? Just because we have kids, I won't tell you exactly what happened to Cicero and his fate, but it's pretty grim. And it's actually accurate in that show. He was a contemporary of Julius Caesar. He knew all the big players you know from history, and he knew them personally. He knew Augustus, he knew Julius Caesar, he knew many of the other individuals, but he was a very learned man. And his best friend was a gentleman named Atticus who lived in Athens, and they corresponded regularly. And they also investigated the natural world, and they wrote books, many different books and texts. Cicero is famous and particularly important among philosophers and classicists because he wrote these letters and they survive to this day. We actually know what he said. And we also know what his friends said, and we see this back and forth. He was a Stoic, so he was a friend of, he thought like Plato, but he wasn't a friend of democracy. He was belonged to a group of Romans that really didn't think the people should have a say, at least not the way they do.
Take your time.
Okay, good. But one of the cool things about Cicero is, and I'm reading Cicero, and I was going to bring the quote, but I didn't because I thought it would be back for time. He goes on for about 3 paragraphs about how cool the night sky is. And he talks about how beautiful and amazing it is, and how anyone who is learned in any way, shape, or form, or at least to be in touch with the humanity, goes outside and looks at the stars. Now, there's no light pollution back then, at least not outside of Rome. And he probably would have been a member of the RASC. I guarantee he would have been. Actually, probably would have tried to become the head of the RASC, and there probably would have been a trail of corpses in the process. It was very bloody politics. So he tells us that by observing the stars, we learn 2 things. First, gods exist. Second, they're communicating with us. So you can see, Plato maintained that the stars were alive. The planets, and that they were imbued with divinity. So you see this carrying forward into the Romans, and this is 300 years after Plato. So this is coming through a succession of philosophers who study that can probably trace their lineage from person to person to person to person to person right back to Plato and Aristotle for that matter. He says that in the case of such vast movements and alterations of the planets, we should conclude that such great operations of nature are directed by some intelligence. That intelligence is that of the gods, but since order and law is the nature of the universe, and that law is governed, it follows that the God which is responsible for law should occupy the highest place, Jupiter. Now you notice Saturn is pushed out, eh? Saturn at this time in the cosmology has been actually chained to the stars because he did very bad things to his kids. And Zeus, Jupiter, his kid, had enough of this and tied him up. And then all his kids popped out. It was just weird, piled upon weird to get into that mythology. The point being that Jupiter for the Romans represented law and order, the state. The laws of the universe have to be governed by something. And they believed there was a rational order to things, and this was being directed by Jupiter. So as for the wanderers, he says, remember I said he's a curmudgeon, right? They're falsely called wandering. Basically because their movements have purpose and they follow rational laws. They're not wandering. Aimless people wander. So next, just to bring us up on a couple more Romans of importance, you've probably heard of Pliny the Elder. He was Gnaeus Plinius Secundus. He died on August 25th, 79 CE. He was killed at Pompeii. Not at Pompeii, he was actually at Stabii, which is just southwest of Pompeii. He was a naturalist. He was also the commander of the Roman fleets. But he was a brilliant natural scientist. Brilliant for the time. The other individual, Gaius Julius Hyginus, we know a lot about Eratosthenes from him. He lived a little bit earlier, 64 BCE to 17 CE, and he was a slave of Emperor Augustus. He was freed. The Romans didn't have the same conception of slavery as we do at all. Individuals were constantly freed. They became part of society. Slavery wasn't upon racial or ethnic lines. It was a much different approach to things. But his job was superintendent of the Palatine Library. Now, a really important point here about the information we have from antiquity is we know that there were libraries with hundreds of thousands of texts in them. Library of Alexandria. There were numerous ones. Libraries in Rome. But they were burned either through fire or the Christians destroying them. We have archaeological evidence of the intentional destruction of some of these things. So we have lost vast amounts of information. I remember when I was studying philosophy, I was like in third year or something like this. We'd read something, and I can't remember the source, it was from antiquity, that said that they had a history that went back another 20,000 years. Remember, the Greeks had been collecting all this information and putting them into libraries. So we've lost an awful lot. So what we have is sparse at best. However, this man was in a good position to collect a lot of information and provide it to us. So Pliny the Elder, from these two guys, we're going to get some information. Pliny called Saturn Sidus Saturni, which is simply, Sidus means star, heavenly body. To Pliny, it was the smallest and it was frozen cold. For Hyginus, and I'll go back and forth on the names because I was telling Paul this earlier. I had a bit of a headache earlier, so I take a pill for my migraines, and every now and then it causes me to go off tangent with my pronunciation, which is bad at the best of times. Reinforces the name that it is the star of Helios, and others say Kronos. Eratosthenes claims it's called Phaethon, son of Helios. By the way, that's a direct quote from him. Pliny calls Jupiter Jovis, or simply Jupiter. So we're beginning to see the names of Saturn and Jupiter settle. They're calming down here. He says Jupiter is thought to be temperate because it's influenced by Mars' excessive heat and Saturn's cold, so it's in the middle. The names of Mars are given as Martis and Hercules, basically Mars and Hercules. But building on the explanation for Jupiter's temperament, Pliny tells us clearly that Mars is excessively hot and, quote, owing to the proximity of the sun, it has a fiery glow. It's red because it's hot, not because it's bloody. Evidence for this being consistently held view of the planet Mars also comes from Ptolemy, who said, the nature of, this is again a quote from Ptolemy, the nature of Mars is to dry and to burn in conformity with his fiery color and by reason of his nearness to the sun. The tradition which has consequently been handed down is that Saturn is cold and Mars is dry. Ptolemy also added in his Tetrabibulus, which is a book he wrote on astrology as well, that Mars had a destructive and inharmonious quality. Not warlike, but inharmonious. Huygens also gives us what I think is the most awesome explanation ever for how Mars got its name, and this is cool. Okay, so he says it is, quote, called Ares, the star of Ares, and others say it belongs to Hercules. But since Aphrodite inflamed him, Ares, with passion, love, she called the star Pyros, fire, indicating this fact. If you will, Venus named Mars fire as a taunt. Oh, you're in love with me, you're not going to have me, and I'm going to tease you with this. And that's basically a double-edged sword for love. So it's kind of a cool story from him about how he thought the name Mars came about. Here we go, we're almost done. 2 pages, or a page and a half. So Pliny tells us that Venus is called, I'll use the English terms, Venus, Juno, Isis, and Matris Deum, Lucifer, Vesper. That's not one name. That's, I think it's 7 individual names. 6 names, 6 separate names for Venus. And the Matris Deum literally means mother god. We're back to the fertility stuff. And this supports the claim that Venus was associated with being the source of birth in all things. He also called Venus a very large star and rival of the sun and moon because of its ability to illuminate the day before the sun rises and the night after the sun sets. And this likely means that they thought the morning and evening twilight was actually heralded by Venus, either as Hesperus in the evening or Lucifer in the morning. It is this one of the few references to the size of the planets that we actually get from ancient reporting, because they really didn't think in terms of size. It was these other attributes. So we also see the same reference in other sources from antiquity. It's also referred to that when Venus prolongs the day, that it is the deputy for the moon. So you can see it. I went outside, actually sat on a hill, and I about a week ago and looked at Venus setting, and I tried thinking like this. You see Venus in the sky, it's coming down. The sun's gone down, but you still have twilight. They attributed, one set of individuals would attribute that light to Venus. So it's an extension of the sun. As to the apparently growing list of names for these planets, Pliny gives us one of the few quotes about this matter. He goes, quote, "There's great competition to give it a name, some having called it Juno, others Isis, others the mother of the gods." Again, for Venus, there's no mention of beauty given, which is a common reason given today for how Venus got its name. But what we see is that he identifies that the names of the planets are being competed for. There are many different sources trying to get the names of the planets. This is why in ancient sources of antiquity, we see 3 or 4 names given whenever a planet's mentioned. In translation, it whittles down to 1 or 2. So Mercury. Mercury is associated with Apollo, and sometimes known as Phobos, meaning radiant light, and called the star of Hermes, or Stilbon, meaning small and bright. It's actually, in Attic Greek, means gleaming. And this is, Hyginus says it's attributed to Mercury because he established the months and first perceived the calendar. Okay, here we go. So this is a little bit of academic part. And there's a couple of questions that popped up, and I called a buddy of mine who went to grad school with, as a prof at York, and teaches this. And I'll tell you what the question is in a minute, and we didn't have an answer, and I talked to a couple of theologians that I know, and with PhDs, and they again had the problem with this. So for a moment, I want to compare the reasons commonly given today for the origin of the names of the planets with how people from antiquity may have interpreted that. The contemporary reasons for the names of the planets fall into two groups. So if you were to go to the IAU website, you're going to see these two categories. The first, the names are rationalized by myths of the gods' creation, importance, lineage, or the cause of placement in the heavens. This is Saturn and Jupiter. The reasons that are given to us today for Saturn and Jupiter neatly fall into this grouping. And I'll just quote here. The largest and most massive planet was named Zeus by the Greeks and Jupiter by the Romans, as he was the most important deity in both pantheons. The Roman name for the Greek Kronos, the father of Zeus and Jupiter. That's for Saturn. As for the modern grouping reasons, the second set, they're rationalized by associating a physical feature of the planet as observable with the naked eye. Remember, this is all pre-telescope, with one or two traits of the god for whom the reason for naming is given. So we see today, we're told Mercury was named Mercury by the Romans because it appears to move so swiftly. You heard me already mention from sources of antiquity, they thought they moved at the same speed as the Sun and Venus. No isolation of its speed. There's a few sources, 6th century, that may mention that, but not in that context. Venus, the Roman name for the goddess of love. The planet was considered to be the brightest and most beautiful planet or star in the heavens. The one quote that I saw that referred to it, where you might be able to interpret beauty, was that Aurora had a child who was said to be a rival in beauty to Venus and was thus named for the planet, but as an attendant to Venus, but not Venus being called beautiful. It was a male figure that was associated with this, and that's probably the only example that I found, and that was in a mythology that was written in the 6th century. Mars is named by the Romans for the god of war because of his red blood-like color. Again, we don't see anything talking to us necessarily about the red blood-like color being a reason. We see red being attributed to fire and its proximity to the sun. It's related to their cosmology. So, in the cases where the names of the planets in antiquity are given as shining, brilliant, bright, fiery, they're competing names with those associated with the planets and a god. So there's competition in antiquities we saw from Pliny for the names. Also, the individual gods had many different competitors. If you were to go from one town to another town, you would see Venus given 3 or 4 different names. There'd be a temple to Venus Genetrix here. There'd be or Mars. You'd have Mars Stator, Mars Altor. Different names and different attributes of these gods. They're not the way we conceive of deities today, with this all-encompassing if you will, personality that sort of rewards you and punishes you. That relationship didn't exist in antiquity. But in cases where associated with a god, the planet goes by these names, we're still not named as a god. It's an association that occurs. This leads to a competing and eventually dominant reason, I think, that the planets were named from antiquity, is that it can be associative naming based on the role and status of the god in the pantheon, as well as its influence on human affairs and influence on the phenomena of the natural world. This goes hand in hand with the creation myth of the gods and the tales of their placement into the heavens by a supreme deity for the ancients, but more reflective of our current explanations for planets like Saturn and Jupiter. There's that pill kicking in. So to wrap up, I'd like to end with a quote from Cicero. We alone of animate beings have learnt the risings and settings and courses of the stars. The day and month and year have been identified by man, and the nature, extent, and date of the eclipses of the sun and the moon have been ascertained and foretold for all future time. By contemplation of these things, the mind arrives at knowledge of the gods. So I hope you've learned a little bit about the history of the naming of the planets and some of the controversy on the matter, and I hope you'll keep looking up and have clear skies.
Wayne?
If anybody has any, want to fire a couple questions, you're more than welcome to, if Paul will allow it.
Just, are we good? I think we've
For a
got
few minutes.
for a couple.
I won't take any crazy questions.
I've got one for you, Wayne.
Sure.
If the prevailing view around the time of Pliny was that the planets were alive, what was the prevailing view of the other stars? How did they see them other than points of light? Was there?
This is actually really, this is an important point that in the time constraint I was thought I'd talk about, but it's a bit more complicated. It goes into cosmology. The idea of remember the atomists got pushed aside, who thought that everything was made of infinitely small particles that were built up and built up and built up through a process of accretion into solid matter, and when they perished, they went apart. They believed that there were 5 elements. We had earth, we have air, we have water, we have fire, and we have ether. And it was believed that the stars were physically above us because they were lighter and they were composed of ether and they were burning in fire. So this rarefied element is what they're made of, and they're fixed to the heavens. And the explanations that are given range from, they were basically holes in the cosmos through which, the great light would shine through, to that they're actually fixed to the sky as fire. There's a range of different things. So they didn't give much thought to the individual stars in the background, which is interesting. The constellations, I said to stay away from astrology. One of the things that Seneca tells us is that he writes this rather cryptic line that he says, we owe the Greeks the names of every star and planet because they did it 1,500 years earlier, which does not correspond to the time of philosophy from the Greeks. Remember, Seneca's writing the time of Emperor Nero, and Plato is 360 BCE. So we're seeing this addition of another 1,200 years to that time frame by Seneca. So that's lost to us. We don't know that bit of information.
The picture you've got up there right now.
Yes.
25 AD.
Yeah.
Was it commonly known that the world was a sphere?
Yes.
It was commonly
Absolutely.
known.
I believe it was Eratosthenes, wasn't it? With his, if I got the wrong guy, get me right. Yeah, Eratosthenes. Looks in the well, sun goes over top, no shadow, goes however many stadia over where he knows, measures, he gets a 7-degree, I think it was 7-degree variance, uses basic geometry to calculate the circumference of the Earth, and he works this out very close. They also knew from ships going over the horizon, by seeing the masts on the ships, that the Earth was round. They also, because of geometry, and the base 60, this sexagesimal geometry that we have, 360 degrees, comes from the Babylonians. That it implies that things like Aristotle thought the sphere, the circle, was the perfect shape, Earth being the center of all things. In later religious dogma becomes perfect. One of the interesting things, and this is actually no small point, one of the reasons to believe that we've had problems actually understanding the nature of the cosmos was because for so long, for literally 1,500 years, we attempted a geometric solution to the movements of the planets as opposed to a mathematical solution. Now when you see people like Kepler coming into play, they begin to drift and move away from that geometric. I mean, we get these crazy, everything's got to fit into a triangle, everything's got to fit into a tetrahedron, or the perfect shapes of Plato. So yeah, in short, we knew the Earth was round. Absolutely.
Time for one more, if there is another one.
Yes, I see someone in the corner.
How did they interpret comets?
Comets were bad. Generally, comets did bad things. They really didn't understand them. There was was either Pliny or Cicero had mentioned that he thought it was pieces of the heavens falling off. And that's interesting because that's closer to an approximation of what they actually are, but they thought they're parts of the firmament, which is what they call that outer sphere where the stars were attached, dropping off. They also thought it was an omen from the gods, and they were very bad. When Julius Caesar was assassinated, it's believed that there was a comet in the sky. They also, contrary to the notion that it was, actually, everything in antiquity has two sides. So you can almost answer for anybody an answer. The other thing they thought comets were souls being lifted up into the being deified. So Julius Caesar is deified, turned into a god. His being is rising up on the comet. A common thing that was done when Roman emperors were when they died, Romans cremated everybody. They would hide an eagle behind the funeral pyre. And as the funeral pyre was consuming the corpse of the emperor, an eagle would be released and it would fly up to the heavens. And that image I showed you earlier where you saw was Mithras holding the eagle is part of that. The eagle's releasing the soul to the heavens is sort of a metaphor for the comet. So it's not a perfect answer, but it's in the ballpark.
Wonderful.
So thank you very much. I hope you enjoyed this and weren't too bored. I didn't seem to be sleeping. Thank you. Thanks, Paul.
Thank you. That was very informative. I enjoyed that. Thank you. All right. Just before our break, I'm going to bring Chuck up. There he is, eager to go. And he's going to pick your brains with a question. There you go, sir.
Yeah, good segue into the trivia with Venus. The rules, no fair Googling. If anybody's caught Googling, they owe me a beer. The guy with the person with the most right question wins a shatter cone. And I'll leave the shadow cone up here. You can look at it at the break. It's a result of an impact. So, what do we have? Well, we have the transit of Venus. I saw the last two of them. They were just great. Do I go in the right? Oh, here we go. Now, there's a connection to this part of the United States. Holy mackerel, look at all the craters. Whoops. Now, where's mine?
The rate button.
Which one's the laser? Oh, here we go.
Laser.
So look at all the craters, especially in this area. Okay, what's the connection? The guy with the most correct answer, wins the shadow cone. If nobody comes up with the answer, I'll give it away for the door prize. Enjoy the break.
For the extra, right?
And we have Google monitors there.
Yes. Yes, I have spies.
That's right.
So here's the shadow cone. Have a look at it.
Thanks, everybody. And for those that donated to Mother Hubbard's cupboard before the meeting, much appreciated because it was looking pretty bare there. So excellent. Thank you. All right. Back to Mr. O'Dale. He's going to reveal all.
First of all, the winner. There is a winner, but he donated the shadow cone. So I'll tell you who won it after. And the person that has a shadow cone, if you want more explanation, just come to see me after the meeting, and we'll enlighten you more. So, what is the connection between these three? Well, I'll tell you a story.
Is it that you can travel across all three of them at the same amount of time?
Close. Okay, 1761. There was going to be a transit of Venus, an excellent segue in from Waynestock. And there's two surveyors that left England. They were delegated to go to Sumatra to observe the transit. 2 days out, they ran into a French frigate. Now this was during the 7 Years' War, and they got blasted up quite nicely. So they returned very quickly, and the two surveyors sent a letter off to the Greenwich agency and said, take this job and shove it. And they got a letter back the same day. Back in those days, apparently mail went twice a day. And they were told that if you quit now, we'll make your life a living hell. So they had a reassessment of their situation and got on another ship. And they made it as far as South Africa. And in South Africa, they couldn't make it any further because they ran out of time. So being surveyors, the first thing they had to do was actually pinpoint the exact position where they're going to observe the transit, because they had to time the transit, then translate it into a piece of, or exact position on Earth. So with the equipment they had back in those days, they did a very, very accurate position for Table Rock in South Africa. And the position they got allowed the English, the Royal Navy, they knew the position or the distance between Africa or the Table Rock and Greenwich to more precision than they knew the distance between Greenwich and Paris. So these guys really knew what they're up to. So they did the transit, and there is a guy named Simon Newcomb. He was part of the U.S. Naval Observatory, and he went through their data, and gave them one of the highest marks for accuracy of their monitoring of the transit. So these guys really knew what they were doing. So, with that reputation, this is before the American Revolution, all these guys here were putting up borders left, right, and center, and of course there's arguments. My land is here, my land is there. So they hired these two surveyors to pinpoint the borders between these states, specifically Maryland and Pennsylvania. And they did it with excellent accuracy. And one of the methods they used for gathering latitude was monitoring the moons of Jupiter versus time, etc. It's very complicated, but they did it. And again, they did it with extreme accuracy. So who were these guys? Aha! So, this is where the name Mason-Dixon line came from, was from the names of these two surveyors, Charles Mason and Jeremiah Dixon. And Dixie, we think, came from Jeremiah's last name, Dixon. So that's the first part of the connection. But what's the connection on the moon? Well, the winner of the shatter cone didn't know that, but
I think I do now.
you do?
I like the lunar method of determining longitude. I think.
Close, but no.
No? Okay.
Anyway, just more maps of the Mason-Dixon line and Dixie. So, on the moon is a crater named after Charles Mason. So hence the connection. So, our winner here donated our shatter cone. Thank you very much. We love it. So, I tried to make it as Google-proof as possible, and I don't think anybody could Google that. Thank you very much.
You're going to have another one for us next month?
I'll try.
All right. Actually, is Wayne still here? I've got one for you, Wayne. You know, there was something that you said in your talk there, and I've often meant to Google this, but I have not, and maybe somebody in the audience knows. But if not, here's one for you to research. You mentioned that the Greeks knew that the world was round. One of the ways they knew that was by watching sails and masts go over the horizon. Now, that was 1,500 years before the telescope was invented, and if the horizon is some 12 miles away for a 6-foot-high person, how could they possibly see that? You have the answer? Okay.
With another one. They have multiple reasons, but they also, you're familiar with the these, like 15-story high lighthouses. These things were actually quite common in Italy, so they could get quite elevated.
Okay.
To see.
And so they see it from the top of the lighthouse, but not from the ground level.
Possibly. That's what I've seen.
Interesting.
That's a guesstimate.
I'd never heard that. Yeah. Yeah. Interesting. It's still a pretty long way away. You'd have to have pretty sharp eyes there to see a sail at 12 miles, I would imagine. Anyway, thank you. All right, that was good. I think we're... Yes, Chris, I knew there was... I was wondering where you were there.
Just a very short little talk, not so much about Starfest in general, but about one particular event at Starfest this year that really impressed me. Most of you probably know this, but for those who don't, Starfest is the largest gathering of amateur astronomers in Canada every summer, northwest of Toronto, upwards of 1,000 amateur astronomers, either camping or trailering or tenting and so on, in a field set up with telescopes with fantastic talks during the day, typically some great storms and hopefully one night of clear weather, and sort of great camaraderie and meals. Before I talk about the one event, I want to bring you back 2 meetings. And those of you who are here probably remember a talk by Paul, who gave a tribute to Chris Hadfield soon after his return from the space station. And Paul did, I think, a really good job of giving the background to Chris Hadfield's trip there, and did the obvious thing and played the Space Oddity video that was taken off of the David Bowie song. But felt that I thought Paul had done a really good job. So I get to Starfest and find someone was snooping on Paul and stole his idea, and also did a tribute to Chris Hadfield. And generally they just showed the same Space Oddity, and I was a little bit disappointed with the tribute. And as it was coming to the end, and I'm thinking, Paul, you did a really good job, and they didn't quite match yours. Then when I thought it was over, they did this.
Greetings, Starfesters, from the International Space Station. I'm Chris Hadfield, commander here of Expedition 35. I understand that your event is a gathering of amateur astronomers, and that you've brought, of course, your telescopes out to observe the night sky. Well, I brought something as well. You know, from here, when I look at the stars, you wouldn't believe the depth and the textures and colors where the stars don't twinkle with no atmosphere in the way. When I look at the moon, and I have been my whole life, I see a scarred history of what the world could look like and the galactic shooting gallery that we live in. When I look at the sun, I see such raw, unadulterated power and portent and untapped resource. I invite all Starfesters to keep looking up through our atmosphere on your telescopes, your binoculars, or visually, just to observe the universe. And I hope you all have a great conference.
Why didn't we think of that, Paul? We could have done something like that. I'm really impressed that they pulled that off and kept it a secret. Obviously, Chris Hadfield had already returned to Earth, but that blew people away in Starfest to have a tribute like that from Hadfield.
Excellent.
Yes?
Question. Did you know that he's actually giving an interview tomorrow at Film Fest?
I didn't know that.
Yeah, it's free. It's actually on one of the free stages. It's going to be at Hogsback Park. Interview with Chris Hadfield.
I hope people have all heard that. Chris Hadfield tomorrow at Hogsback. Cool.
Oh, it's at 5 to 6 p.m.
5 to 6 p.m.?
Yeah.
Yeah, okay, great. Thank you for that. All right. We have some cool observations. We'll motor right along so we don't run out of time. First up, Mr. Banks. Are you with us, Mr. Banks?
So this is the star party we had, and this is a bit of the sky glow we were getting off of Ottawa. I'm not sure what order these are in, but anyway, I think with this one, if I'm not mistaken, you'll see Andromeda somewhere.
Well, let me
A little bit, or if you can see
interject.
it
It is Andromeda.
better. It is. Excellent. That's annotation for you. Great. So I did a little sequence where I did the 18 millimeter. So I shot this with an 18 millimeter lens. Well, it's actually a zoom lens. It goes from 18 to 105. But this one I shot at ISO 1600 at 18 millimeters, and it was about 13 seconds of exposure. And then if I hit next, I zoomed in a little bit to 40 millimeters. You can see it in the middle there. And again, 13 seconds at ISO 1600. And this is a max of my lens. It's 105 millimeters. And this was not on a guided tripod or anything like that. It was just a standard photo tripod. And, didn't mean to do that, but you can see Andromeda in the middle there. Ish. The galaxy, it's a bit hazy, but that's because there's atmosphere and it's a galaxy. So, well, we have atmosphere. That is a galaxy, yeah. This is some just PR shots, if you will. You can see everyone's sort of looking at the telescopes, the glow on the horizon. You couldn't actually see that with your eyes. That's because it's a bit of a longer exposure. I had to bring down the f-stop a little bit so that you can get the star effect on the lights. It just looks neat. But yeah, the sky wasn't glowing that much at this point. It's just the camera brings it out when you do a bit of a longer exposure. So people were actually looking at telescopes and stuff like that. This is the Dobsonian. This was the biggest one. I'm not sure whose it was, but yeah, he had it set up. It was huge. And then again, just more crowd at the star party. It was pretty busy, actually. I was impressed. Somebody using an iPad to do a virtual reality thing. And then the ISS came through. So this is the ISS rising. Somebody helpfully pointed it out with a green laser, which was excellent. And I have a few shots of the ISS. The people are ghosting a little bit. That's because of the length of exposure. And then it's sort of passing directly overhead and then setting in the east towards Ottawa. You can see the sky glow coming up a little bit on the right there. And I think that's it for the photos. Maybe one more, and just ISS setting. Yeah, actually, it is. Right near Andromeda right there. So, there you go. 2 for 1. Oh, and then I'm not sure what I did there. Oh,
Big Dipper.
Big Dipper, of course, you can see that. On this screen, I can see a lot more stars, so it doesn't stand out as well. Up there, you can see it. So, excellent. Thank you.
Thank you, Mike. Do a segue to the green laser?
Do we?
Do a segue to the green laser?
Okay. Yeah. Just
You want me to say something, or
just yeah.
point it out?
Is Bo going to do that for us? Okay. Interesting observation there from Mike's slides there. When we saw those, we saw the use of the green lasers, and it sort of it started a little bit of a debate for us there, because the site of the Carp Star Party is actually fairly close. It's only a few kilometers away as a crow flies from the Carp airport. And it was our sort of understanding that there might be some restrictions there in terms of using green lasers within 10 kilometers of the airport. So just a bit of a heads up there. Bill Wagstaff is going to look into this for us there, and probably next month he's going to let us know what the deal is, whether it's a recommendation or whether the man could slap a fine on you. I'm not really sure what it is in Canada. I know in jurisdictions in the States they're pretty stringent with these things.
RASC policy is no use of green laser pointers within 10 kilometers, so I think you'll find that tomorrow night Star Party there won't be any green lasers.
Yeah. There may not be any stars either, but that's another thing. Okay. All right. John, come on up.
I have 2 images of the Nova Delphini that was discovered on August 14th. It was actually by a Japanese amateur astronomer, I think photographically, before it reached maximum magnitude. Well, I was able to get, I have 2 images here. This was August 23rd, there was still a bright gibbous moon in the sky, which explains all the sky glow in the background. It's actually moon glow. But I guess the Nova is just about in the middle there. The star right above it is a Hipparcos star, which actually 5.8, and in my binoculars it appeared almost the same brightness. In the photograph it's a little bit dimmer, so that would be somewhere around 6 magnitude at that point. Then the next one was just taken actually this morning, probably about 20 hours ago, around 1:30 a.m. And there it is again. You can see it's dimmed somewhat compared to that magnitude 5.8 star. Interesting thing is, though, they're reporting the light curve is declining much more slowly than they expected for a normal nova. They're starting to call it possibly what they call a slow nova, which means it may remain visible for 6 months. And in fact, there was one slow nova in the same constellation in the 1930s that leveled off for a while and then had a second outburst before it continued its decline. So anyways, this one is an interesting one that AAVSO is telling us to keep an eye on it because it may have some surprises still. That's
great. Thanks, John. Mr. LeDrew.
This was taken on the night of the last full moon, which was called a blue moon. I saw in a news report, and they even showed a photograph as part of the newscast that was very strongly blue tinted and deliberately. There was nowhere on Earth where the moon was going to see such a strong blue color, and the newscaster, Graham Richardson, actually, it was the local CTV newscast. He even made a little bit of a quip at the end after the image had gone off, saying something about how it was, very blue and very bright, as though he really believed that it was a truly blue moon. The depth of ignorance of some of these newscasters makes me shake my head, I tell you. Anyway, I took some photos with a camera that Rock Mallon had lent me. It's called the SSI, or Solar System Imager. It's not a very big chip. It's about 1.3 megapixels roughly, about 1200 by roughly 1000 pixels, with fairly small pixels, which allows you to get fairly good resolution. He wanted me just to try it out on some deep sky objects to see how the noise level is and so on. I did some early tests with a bright moon in the sky, and it doesn't seem like it's really all that good for any kind of deep sky imaging, but I have a C8 that I just set up on my balcony. I didn't really do much of a polar alignment, but the exposures are so short you don't need to worry about that, even though the moon was slowly drifting upward in my view. It wasn't enough to wreck anything, but on that night the seeing was pretty bad. There was a combination of kind of like the rubber moon effect as well as all kinds of lower, smaller scale, fairly rapid blurring in and out. So I ended up rejecting a fair number of images. I would shoot one, review it. If it didn't look good, kill it, take another, and so on until I collected some that weren't so bad. This one here, it's a mosaic of 3 images. So the original image was fairly large in terms of the pixel count, and it shrunk down here for fitting on this 1024 pixel wide display. And this is looking right down at the southern part of the moon. The south pole of the moon would have been somewhere over here, roughly. Just out of the frame down below would be the bright crater Tycho. And Brian McCullough would probably know the area here of these lava-filled craters in this region of the moon. I found that fairly interesting looking. But here, the image is upside down because this was the southern part of the moon, so it was in the lower part on the lunar limb. But I found that the effect was a little more dramatic when I flipped it upside down like this. It kind of gives the impression like you're going into lunar orbit. And in the next image, I think there's 2 other ones included. Because it was at full moon, of course, away from that southern limb where you could see some shadows in the craters. Here everything is just being lit face on by the sun, so all you're seeing is just differences in the reflectance or the albedo. And this is the bright crater Copernicus, just about in the center of the view. And what I find interesting with a lot of still relatively youngish craters is you'll see that they look like little bullseye circles scattered about the moon's face, indicating that's the rougher terraced walls, which are more reflective. They have more of a rougher texture, I guess, and you get more efficient backscatter than some of the more finely textured material, I guess, that's sort of surrounding and in the crater floor itself. It's an interesting aspect, anyway, of looking at the moon when it's full. And of course, the very younger craters typically have pretty high brightness to them. They look like little, fuzzy star-like blobs scattered about the face of the moon. And you'll notice here with Copernicus that it's surrounded by this very large ejecta blanket of all brighter colored rays. But another crater that's roughly similar size on the moon, Tycho, is surrounded by this darker halo of glassy-like ejecta material that has a lower reflectance and looks like a bit of a fuzzy, darker annulus surrounding it. And of course, we have some very prominent ejecta rays, some of these that wrap a considerable fraction of the moon's circumference around it. They extend over much of the visible face of the moon. And once again, we still see some of the other craters that end up looking more like little ring-like features because of the bright walls that are more reflective. And those are my lunar shots. I'm not really a moon type guy, but I thought I would try the camera out that way. And it's certainly a fun thing to play with, unlike deep sky imaging where you're doing exposures for many, many seconds or minutes. Here is just a few milliseconds and you've got your image. Thanks.
How did you remove the blue tent?
Thanks, Glenn. Never thought I'd see you doing lunar imaging. Never too old to learn, eh?
Yeah, so I guess every once in a while one can actually appreciate that cheese devil in the sky.
Absolutely. You gotta live with it, so. All right, Bob? Bob, are you, oh, there you are. Oh.
Right here.
It was clear last night. So I was so surprised that I went out, set my camera up, and a friend of mine came over and set his telescope up beside my imaging set up and basically walked around and bumped my stuff all night.
Did we get a chance to guess at the object?
Yeah, it was printed on it a minute ago.
Oh, I didn't see that.
Yeah, so this is just a luminance of M33. And you know, this stuff here, some of the bright stuff is pretty interesting sort of hydrogen alpha area. I will get some luminance on this at some time in the future. And at the same time, I imaged a little bit on NGC 6992, which is the eastern veil. And again, just luminance. This is largely hydrogen alpha and oxygen 3 area. But in luminance, there's still quite a bit of detail shows up. And again, I'll get some color on that a little later on. Anyway, thank you very much.
Okay, so here's one that just got laid on me. This is a surprise, and I didn't realize this, but here's an image of that was sent in by Deborah Saravolo, who couldn't be here tonight because apparently they've moved to BC. And this is their backyard. So they're out in Osoyoos, they're Jack Newton's stomping ground there, and apparently they bought a place there and they've moved there, and they get a chance to look down on the clouds from their new observing vantage. So good on them, and thanks for sending that, Deborah. That's good. News to me.
So Paul.
Yes.
So the Deborah had emailed me about that. She was just days before they left. So the name of the mountain that they live on?
Yes.
Anarchist.
Anarchist.
And it works
for Peter?
Yeah.
that fits well. Thank you. Mount Anarchist. All right. Excellent.
It's right on the, they're almost right at the border of Osoyoos of Washington State.
Of Washington State? Wow, that's wild. Oh yes, that guy. I managed to get a few shots myself of the Nova. This was 2 days after the discovery announcement there, and so I just took out the camera with just my DSLR with a 200mm telephoto lens, and I put it on one of the new Ioptron sky trackers there, which is actually a marvelous little tool there, and just banged off a few shots there, and you can see it glowing quite prominently there. I wanted to actually get this through my telescope as opposed to just a telephoto lens, so the following day I set up my 80mm Apo, and everything was looking good. I had some other targets in mind which I was shooting at the time there, and I flubbed my timing because by the time I turned it over to the Nova, it was in the trees already. So, but I thought I'd include this shot because it's rather interesting. This is the unobstructed star field. This is a tree nearby, and that's the Nova shining through the trees there. So it was quite prominent, and it was definitely visible to the naked eye there. So it was quite a treat there. I had to wait a couple days after that because of the atmospheric conditions, but I did actually manage to get one of the Nova through the telescope there, and that would be there. So a pleasant little object to have a look at, Nova Delphine. All right, and I think, oh, thank you. And last but not least, Mr. Roy. Where are you? There you are. Come on up and tell us all about Madawaska.
Do I have to be at the microphone? I prefer to be in.
No one will hear you.
They won't hear me?
They won't hear you. Just reasonably close.
So this is the pointer here?
Yeah, lasers in the center.
It is pretty bright. Okay, my name is Frank Roy. I'm the CEO of Madawaska.
They won't hear you, Frank.
Oh, sorry. Madawaska Highlands Observatory. And I'll tell you a bit about it tonight. What happened?
You must have gone right button.
Oh. Okay, about the MHO, let's cut off the top there. The Madawaska Highlands Observatory is structured as a first-class tourism facility. It would host the two most powerful telescopes in Canada, the regional tourist destination, a K-12 educational experience. It would be privately funded and managed, and it's Ottawa-based.
Frank, look at this screen, then people can hear you and see you.
Okay, so what is the Madawaska Highlands Observatory? It's a premier tourist destination in Ontario, and it would actually be the premier facility of its type in the world. Regional prosperity economic engine generating upwards of 250 jobs, $200 million in visitor spending over 10 years. National Center for Observational Astronomy, I've queried the professional astronomers, and they would co-host instruments at the facility, and plus we would have the two most powerful telescopes in Canada. A world-class facility and offering. The site will have a state-of-the-art visitor center, an 8K planetarium, and large 30 and 40-inch public telescopes. And of course, the location is extremely important. It'll be situated on the darkest night sky in Canada, where the Milky Way actually casts a soft shadow. And the building itself would be a bit of a showcase. It'll be off-grid and be a LEED Platinum building. So in terms of the economic prosperity, which is very important to the people who live out there, we're targeting about 125,000 visitors per year, and up to 25% of those could be international. We create up to 250 jobs. Of course, that's a combination of full-time, part-time, seasonals, and so on. $200 million visitor spending over 10 years, 150 million GDP, 70 million taxes, and it'll be a catalyst for economic growth in the region. This model was derived by tools provided by the Ontario government. So the types of jobs that the MHO would provide, there'd be interpreters and tour guides, and we'd be in demand for people with knowledge of the night sky. Hospitality, food preparation, science and technical engineering, marketing and communications, retail sales, procurement, K-12 educational and visualization, managerial and director level, and groundskeeping and logistics. So the location is very, very important to the facility. We've chosen an area almost untouched by artificial light. In southern Canada, it's the farthest you can go to get this kind of dark sky. Proximity to large populations, nearby a major highway, has the right topography and elevation, and it's very isolated from the neighbors. So here we have a sky brightness map of southern Canada, and you can see, whoops, oh, sorry, let me go back.
Left one, yeah, just the left one.
Oh, here we go. Yeah, on the left you see Toronto, Montreal and Ottawa, and the arrow points to the site. You can see why we're in this particular location. And as we zoom in here, oh, yeah, this is a precipitation map of Ontario, and you can see there's a bit of a dry area where we are, and this is caused by the Madawaska Highlands, where the westerly winds uplift, and the Madawaska Highlands dump some of the humidity. So we have quite a bit we have a good location in terms of the climate, microclimate. And here you see on the right the topography of Ontario, and you can see the Madawaska Highlands, and you can see where we are on kind of the western edge of the Highlands. You can see the highest point there is 587 meters. The site is about 450 meters. Here's a map of Ontario. Ottawa is on the right. The 401 is in the bottom here, and this is about 2 hours north of the 401, and it's right off Highway 41, so it's a major access point. And you can see this area here is where we want to be. Go to the next slide here. This is the dark area, you can see over there, and this is transposed to the map, and you can see we want to be in this particular dark area. And there's some logistical considerations. One of them is this bloody 300-meter tower with strobes on it, and so you want to be far enough away from the sucker so it doesn't strobe you. So you got to be about 20 kilometers away, and you want it to be within easy access to the highway. So you're kind of limited to where you can be. And this line here is as far south as you can go to get a perfectly black southern horizon, which is very important because a good part of this facility is driven by the visual night sky. Now, to be more specific, this is the topography of the area. It's near the town or the hamlet of Griffith. It's about a half an hour west of Renfrew, and quite a bit of effort has been spent to find the right topography to locate the facility. And Highway 41 is on the top here, so going down south. Renfrew's to your right, and this is the local county road, and here you have the observatory, which is on the top of the hill, about 450 meters, and the visitor center, which is on the east side of the hill. It's actually a plateau. So the structure has a dual plateau where the visitor center is about 500 meters removed from the major observatory, so we don't have interference for obvious reasons. This is 50,001 topography. And here is the 10,001 topography. The site itself is about 100 acres. It's about a 3-kilometer uphill from the county road. And you can see the way it's structured here on the right-hand side. You're on the side of the hill, so you get a spectacular view of the Madawaska River, about 150 meters above the river valley. And we have the visitor center. We have what's going to be a hotel in phase 2. And there's a little road right leading up to the pro observatories. You can see those 2 circles there. And then also the 40-inch public telescopes are going to be located there. And the 30-inch public telescopes are going to be located near the visitor center. This is a 3D rendering of the facility. It's a 3D rendering. It's about a year old. And here you can see the building. It's going to be about a 25,000 square foot building. The observatories are on the top, and you can see the road going up to the top of the hill there. And this little rectangle there is where the 40-inch telescope, visitor telescope, is going to be. This drawing here is about a 14,000 square foot building, so it's going to be a bit bigger than what you see here. And this is the view from the county road. The hill's about 1 kilometer away, and it's about 150 meters above from where we're looking at now. In terms of the tourist offering, which is very important in the business case, it's about a 25,000 square foot building, 30-inch and 40-inch public telescopes, state-of-the-art 8K planetarium. These are planetariums using 4K projectors, probably about 5 4K projectors, and the shows are actually rendered in real time, so it has a very powerful computer system. So there's about 200 shows you can get off. They're quite spectacular, and with special glasses you can even do 3D. Of course, there'll be displays and exhibits, a cafeteria and boutique. There'll be a secondary 100-seat theater for lectures, and an outdoor amphitheater. There's a phase 2 planned. There's 100 acres, and there's quite a large area near the professional observatory, so we can do quite a large summer star festival. There's going to be a 4.5-star hotel with accommodations and business and weddings and that kind of stuff, luxuries. And the sun telescope with some unique technology to give ultra-high resolution views of the sun, and there'll be an exhibit space in the visitor center for that telescope. So at the core of the visitor experience is looking through large telescopes. Now, we did quite a bit of work to see what was out there in the world of visitor centers for large observatories, such as McDonald Observatory and so on. And what people really appreciate is to be under an exceptionally dark sky at a major observatory and looking through large telescopes. You figure, well, if they're going to some big observatory, they want to see the telescope. Well, actually, no. What they really appreciate is opportunity to look through large telescopes. So we put a lot of effort to get the best telescopes, to give the most phenomenal views you can possibly imagine under a spectacular sky. And the large observatories, which I'll talk about later, they typically use off-the-shelf telescopes anywhere from 12 inches to maybe up to 20 inches. So we got 2 telescopes here. We're going to have a 30-inch, which is going to be the small telescope, and a 40-inch. And one of the things that we wanted to avoid is to get rid of ladders altogether. So we had to design an ultra-fast optical system. Here you can see the man, a 5-foot 6-inch man, doesn't need an eyepiece even looking overhead for a 30-inch telescope, which is pretty unheard of. And the 40-inch, well, I'll just mention this a bit later. So we can see here the eye level of the man is the same level as the eyepiece. And it's a 30-inch telescope, f2.17. The whole telescope only weighs 110 pounds, which is pretty unusual. It's designed with carbon fiber. It's an open back cylinder mirror. The mirror is, I think it's 40 pounds. The secondary is quite large because it's a fast optical system. It's a 6-to-1 aspect ratio on the mirror. It's a hollow mirror with a ribbed structure. And to give you an idea of what you would see, it's got a field of view of 1.6 degrees with 63 times. For a 30-inch telescope, that's unheard of. It doesn't exist today. Now the 40-inch telescope Well, let's just go back here.
Left button.
Yeah. Now, the 30-inch telescope looks pretty puny compared to the 40. just blows me away. The 40-inch telescope will, and the 30-inch will be on a platform elevated off the ground to get rid of the ground turbulence, and we'll actually drop the 40-inch telescope in a pit elevated off the ground, and the eyepiece will actually be at the height of the man. So you'll be able to look through a 40-inch telescope without a ladder, and that's incredibly important because it's very, very dark out there, and basically you trip over things. So you'll be able to look through a 40-inch telescope with a ladder, and the views will be, well, pretty amazing. The field of view will be about 1.3 degrees at 77 times. So something like a Andromeda galaxy, where you can see stars up to 19.5 magnitude or something like that. It'll be pretty astonishing. We designed, these are custom telescopes, by the way. You can't buy these. Well, I guess if you had a lot of money, you could, but the 30-inch one's probably around $45,000. This one here is probably around $150,000, $200,000, but this is a commercial operation, so we can do we can push the envelope to get telescopes that will make people come back to look through this again and again. Now, the building, the visitor center, we have a bit of a showcase in itself. We're using some existing technologies, but it'll be off grid, and we're 3 kilometers from the grid. So bringing the grid in is going to be $500,000. So we're going to take that money and do an energy independent building using geothermal heating, solar cells with batteries, gray water recovery, propane backup, solar thermal, and the lead platinum. That's a construction technology, and that does some very interesting things. Zero carbon, first of all, zero utility cost, and we're going to use the building as a showcase building and exhibit displays around it, and giving tours of the building. So a lot of people are interested in this kind of technology, and of course that will be generating revenue, and it'll pay. Actually, it'll pay for itself in about 5 years, something like that. So the observatory, as I mentioned, will be world class. They are the most powerful in Canada, not the biggest in Canada, but the most powerful because of the technologies and the location and so on. State of the art, of course, and we're not targeting the Canadian astronomical communities particularly. We're targeting the global community because the telescopes are fully autonomous, which means any astronomer in the world could use it, and the capabilities are unique enough that there'll be quite a bit of interest in the global community, and that's part of our business model here, with some revenue generated from that. And it's also a big tourist draw. People will come up and we'll give tours and presentations of these telescopes, and the data generated from the telescopes will actually be exhibited in the building, and they'll be refreshed continuously. And that's one thing that a lot of major observatories don't pay attention to. So these are 3D renderings of the Kellett Dome on the left, 3/4 sphere Kellett Dome. It's about an 8-meter diameter, and the Whitefield telescope on the right. This is a field of view of about 25 full moons, 5 square degrees. And it uses also carbon fiber technology. It's a prime focus system with a 4-lens corrector. The biggest lens is about, it's a huge thing. It's 18-inch lens or something like that. And the camera is the biggest chip in the world. It's made by semiconductor technology. So it's actually they fab it in Bromont, the only fab in Canada, and it's an active optic system, so it's pretty advanced technologically. Now, in terms of performance, I did an analysis in terms of the 5 degrees squared compared to something like the CFHT, which is Canada's most important imaging telescope, and because it does a monolithic field, it's not mosaic, like the CFHT has a mosaic image on it. Up to about 24th magnitude, this telescope here, a small telescope in Ontario, outperformed the CFHT. And I have a paper to show that. So it's pretty amazing. Now this is the chip. It's a 4-inch chip, 112 megapixel. Oh, yeah, okay. A lot of numbers here. I don't want to spend too much time on the numbers. 9 micron pixels, so electron, read noise, and so on. It's cryo-cooled. They have a special gas to minus 100 degrees. So effectively no dark noise. 1 pixel per hour, 16 bit quantization, and it's a monolithic imaging system. Camera we built by an Arizona company called Spectral Instruments. They design cameras for high performance telescopes. They want to do. Okay, yeah, the images are very large, 213 megabytes per image, and you can get an image in just 3 or 4 seconds. This thing will generate a massive amount of data. The optical system is interesting. It was designed by the same optical designer who designed the LSST, the Large Synoptic Survey Telescope, probably one of the world's top opticians. You can see it's a 4-lens system, silica, and one of them is calcium fluoride, the last lens here, right? 6% rubidium on the sides. We expect the scene to be about 1.25 arc seconds on the average. We're using UVS filters. That's the same filters used in the the professionals use UVS filters. They're wider band than the standard aperture filters, and it's an f2.4 system with 2.4 meter focal length. So it's a really fast optical system. Okay. It uses the bond shutter. It's a very large shutter. It's a 6-inch shutter. And this is the spot diagram, and this is the amount of energy from the area here. You can see UV rays, U is ultraviolet, green, the red, near red, infrared, wide band, ultra wide band. And you can see here, this square is 1 pixel. So you can see that the imaging, almost all the light goes into 1 pixel. Even for the ultra wide band, which is 400 angstroms, it's extremely high performance optical system. There was another optical engineer that tried to out-design this system, and after months of trying, he couldn't touch it. Like I said, it's an active optic system, and that's a bit different from adaptive optics. And what it does, it adjusts the geometry of the 2 mirrors, specifically the camera itself, and it corrects for any distortion, mechanical distortions caused by stress on the telescope. 6 degrees of freedom, XYZ, and rotation, XYZ. So it allows all collimation, so on, so on. It's a hexapod, and I won't bore you on the details. This is it's a 24-inch version of the mirror. You can see it's an open back. It's a cast rib structure, and the optical surface is a 1/4 inch. That's very important because big mirrors have an issue with thermals, because thermals can be actually more important, almost as important as the actual optical shape itself. And it has a 1/4 inch optical surface, which means it actually tracks the change in temperature in real time, in seconds. And you have to be about within half a degree to get the best possible scene, because the scene right above the mirror scene really affects the performance of the telescope. So the mirror is cast at the final F, center open back, 50 kilograms for a 1 meter mirror, which is very incredible. 1/4 inch optical surface, and rapid thermal equalization. Now, in terms of a comparative facility, McDonald Observatory in Texas, which is near the Mexican border, last year they got 60,000 visitors. Now, you have to remember that this is way out there. I mean, you've got to drive 4, 5, 6, 7, 8 hours to get there. So it's pretty remarkable they got 60,000 visitors. The nearest city is El Paso, about 300 kilometers. Ottawa, for example, we're targeting 125,000 visitors. The nearest city is 150 kilometers. The big centers are 750. McDonald Observatory, the big centers here are about half that distance. The nearby population, if it gets in the desert, within 200 kilometers, people are 50,000 people. And the nearby population here is 2.2 million people. So that tells you that this is going to be a very, very popular destination. Who will visit? We see 2 audiences. One of them is the tourism, and that's there's a lot of people that live there in terms of cottages, in terms of the provincial parks. 23 provincial parks within 2 hours. There's about 1 million people born to the area in terms of cottages, and of course the people come from the big centers of Ottawa and so on. So half of the population, maybe 40% or so, are going to be educational. It's going to be a huge part of our audience because there's a huge educational component of this thing. And the other half, 50%, are going to be just tourism. And they perfectly match each other because the tourism is typically May to September, and K-12, educational K-12, it's kindergarten to grade 12, is the other part of the year. So we get a more even distribution of visitors during business days. Now, this thing has a very significant support in the local communities. There's a fellow that lives in the area, George Ross. He did a survey of the local people who live there within 20 minutes of there, and he found a 99.5% support. There's a couple of hunters that are upset. Well, what can you do, eh? So, well, we have written endorsements from all the counties in the area, all the towns and townships, and pretty much all the tourism organizations. We see this as a key component of the Ottawa tourism scene, where people will come to Ottawa just to go to this thing and take advantage of Ottawa. And of course, there's about 7.5 million people that come to Ottawa in terms of tourism, so we're going to tap into that and develop packages with hotels and so on and so on. And we also have letters of interest from many scientific organizations like the HIA, the Canadian Space Agency, and so on and so on. So we are looking for investors. We have a very strong business model based on empirical data. Minimum investment is $10,000. We're offering 50% annual dividends, 400% ROI, return on investment in 7 years, and we do that through a share buyback. So for $100,000 investment in 5 years, you get about $500,000. You get your $100,000 back plus another $100,000. And we have a pre-billed offering at 50 cents a share, which expires on November 1st. So I'm the CEO and the founder, and I have another fellow, Greg Bell, who is also an investor and a board member. And that pretty much sums it up. Thank you very much.
We were running a little bit over, so we don't have a great deal of time. Will you be around for that afterwards? All right. That'd be great. I know I've talked a little bit about this already. There's a lot of interest. If you get your funding in place, just one quick question. When do you anticipate construction on this will start?
Construction will start Q2 2015.
Okay, great. Okay, thank you. All right, we're a little bit over, but two very interesting talks. Thank you again for sharing that with us. So, Estelle's pick of the month. Are those? There are video CDs. Okay, so we've got a compilation of some of Simon Hanmer's talks there, which if you've missed them, here's your chance to catch up and check them out. So go see Estelle for that. As you know, Simon is one of our most dynamic lecturers there, so I think you would find these quite interesting. And there are six talks on the discs there. All right, again, just a notice of the Public Star Party on the 7th, which is tomorrow. Did we get a verification on those times, those start times? Are those correct? Yes. Okay. All right, so 6:30, that means you can see where you're going. You won't walk into anything because the sun doesn't go down until about 7:30, but keep our fingers crossed. The forecast is a bit marginal. If it does turn out to be a bust for tomorrow, the alternate date is 2 weeks hence on the 28th. So again, you can monitor our site there for the go no-go decision there. And again, the location of the Carp Public Library, if you're not familiar with it there. The layout itself, coming off the Carp Road there's a road that goes to the Diefenbunker. You'll see the signs for that. And the parking lots where the observing site pose is right down that way. So we'll cross our fingers for tomorrow. So again, Estelle is available. Al is not with us today. Art and Ann are around, obviously, for coffees and RASC membership information. Stephen McIntyre, you can contact him for Sky and Tel and astronomy renewals. The rest of the museum is closed as always, and as usual, the diehards will gather at Kelsey's after the meeting for refreshments. We had 97 folks today. Thank you for coming out, and thank you for all the contributors to the program. Keep those observations coming in. And thanks again to the Science and Tech Museum for hosting this. Complaints and comments, talk to me. October the 4th, our next meeting. So our usual first Friday of the month at 8 p.m. And I guess that's about it, eh? Safe driving, clear skies, and we'll see you all in about a month. Thank you for coming.
Thank you.